In today's video, we're going to be looking at simple and compound interest and how it relates to what we have learned already. So that's your learning target today, is to just investigate and understand the difference between simple and compound interest and to be able to apply it. So you may have heard the expression, money does not grow on trees. However, money does, in a sense, grow in a savings account. In today's lesson, you will apply your understanding of exponential functions to solve problems involving money and interest. So as always, I tell my students, start saving now. Do not wait. I know it might seem not necessary to start saving money as a teenager, but if you can and you have that option, go for it. But let's continue with the lesson. So as a reminder, by now you need to know this, everyone. A is your y-intercept. I'll also refer to it as your starting value or your initial value. It's what you start with. B is your multiplier. What are you doing to that starting value? What are you multiplying it by? So that's our reminder. So let's go over a little bit of vocabulary. We have simple interest and compound interest. So simple interest is interest paid on the principal alone. It grows linearly. And if you don't know what the principal is, that's like the main amount of your loan or your savings. And so if I bought a car and my car cost $30,000, that's the principal. The principal is the original amount owed. And then on top of the principal, the car lending company would be charging me interest. And so when you pay back a bill, you are probably paying off your interest, but you want to make sure that you're also paying off your principal. But in this case, we're going to be looking at savings, and it grows linearly. Okay, so what does this relate to that you guys have already learned? Simple interest is just a linear equation. Compound interest, however, grows exponentially. So now that you know it grows exponentially, what do you think is happening to each term? It's growing by being multiplied from year to year or week to week or whatever the variable is, okay? And then initial value, hopefully by now we're okay with, it's the first term of the sequence. And usually we want x equal to 0. That's where we want to start. So that way when we write our equation, it's just to the x. Technically, there's an x minus 0 there, but since x minus 0 is just x, we leave our x there. Okay, so let's try some examples. You are saving for college. You have $1,000 to invest, and you know of 2 investment options that offer an 8% annual interest rate. So they give you 8% every year of the amount that you invest. You can invest in bonds, which pay 8% simple interest, or you can put your money in a credit union, which pays 8% compound interest. Will the option you choose make a difference in the amount of money you earn? So let's look at these 2 situations, okay? So imagine you have $1,000 on you right now, and you can either put it into a bond with 8% simple interest, or you can put it into a credit union account where you get 8% compound interest. Which one are you going to choose? So let's investigate. First, you invest in bonds, and your $1,000 grows as shown in this table. How does the amount of money grow with simple interest? Well, let's look. From 1,000 to 1,080, are you adding something? You can add 80, right? We have to make sure it works moving forward. Is 1080 plus 80 1160? Yep. Is 1160 plus 80 equal to 1240? Yes, it is. So how does the amount of money grow with simple interest? You are adding a constant to each term. Oops, constant to each term. So what that means is you're getting 8%, but only on the original amount, because 8% of 1,000 looks to be 80. So every year you're getting $80, which is just 8% on your initial value. Okay, $80. By what percent would your balance have increased at the end of the 4th year? Well, we need to first know how much she earned on the 4th year. So I need to add 80. And I get, let's see, 1240 plus 80 in my calculator gives me 1320. So at the 4th year, she's going to have $1,320. It's asking by what percent would your balance have increased. So thinking back to the last lesson where we looked at how to find the multiplier, what we can do is, let me get my highlighter, take this number, divide it by this number to figure out what the multiplier is. And so I'm going to take 1320 and divide it by $1,000. And let's see what that value gives us. 1320 divided by 1,000 is equal to 1.32, which in percent, if you move this over twice, like you're supposed to, it's 132%. So by what percent did my balance increase? It increased by 32%, right? Because 100 is the 1,000, and then 32% is the $320 that was added thanks to interest, right? So if you have the opportunity to put money in a savings account, do it, because just by sitting in there, you're getting free money. Unfortunately, 8% is really high. I'm pretty sure. I worked at Wells Fargo many years ago, and I think the interest rate was like 0.025 or something. Okay, so 8% is pretty high. But just remember, by using bonds, you only rose up 32%. So let's look at what it would look like if you decided to put it into a credit union where you get 8% compounded interest. Okay, so let's see. How is it growing? Explain how compound interest is calculated. Why is there 1166.40 in your account at the end of the 2nd year? So let's look at this. From here to here, it looks like I'm adding 80. But am I adding 80 moving forward? No. It looks like I added 86.40 cents. So it is not, it is not adding a constant each term. Okay, so since it's not adding, we know it's not going to be linear. It's going to be multiplied by something. And how do we figure out what decimal is it being multiplied by? Again, that's where we take one number and divide it by the one right above it. By the way, you can pick any one. You can pick this one and divide it by the number above it. You will still get the same value. Okay, so if I do, let's do 1080 divided by 1,000. Let me go ahead and write this down. I did 1080, whoops, and I divided it by 1,000, and I got 1.08. So that tells me that my multiplier is 1.08. And test it. Is 1080 times 1.08 approximately 1166.40? And it is. If I do it again in my calculator, I get this value. Okay, and so how is it growing? It's growing exponentially. I am multiplying by a constant each time, and I'm multiplying by 1.08. Okay. Now, what will the balance be of the credit union account at the end of the 4th year, and by what percent will this account balance increase at 4 years? So to get this 4th one, I'm going to multiply by 1.08. So let's do 1259.71 times 1.08, and I get approximately 1360.49. Okay, so that's how much I have at the end of the fourth year. And by what percent will this account balance increase at 4 years? Hopefully you can do this by yourself because we did it in the previous slide where you take this number, divide it by this number, right, to get what your percent will be. And so let's do 1360.49 and divide it by 1,000, and you get 1.36 and so forth. Okay, so we only care about the 1.36. Oops. And so what will the balance be? 1,360.49 cents. And by what percent will this account balance increase at 4 years? Since 1.36 as a percent is 136, it grew by 36%. Okay, so by putting your $1,000 into a credit union where you're getting 8% compounded interest yearly, you're growing by 36% to the fourth year. So let's think about this all together. Now let's gather our thoughts. Which type of account, a bond with simple interest or a credit union account with compound interest, grows more quickly? Well, after experimenting and investigating these two, what was the percent increase for the value of the bonds? If I remember correctly, hopefully I do, it was 32%, right? And what was the percent growth in the credit union that we just did? I believe it was 36%. So where does your money grow more quickly? And it would definitely be where your money is being compounded yearly, as opposed to the simple interest, where it's linear. Okay. And that's because in a simple, you're only adding the interest you got from 1,000. Whereas compounded, you're earning interest on your new value each year. So here, you only got 80 bucks. However, from here to here, you're no longer just taking 8% of your initial value. You're taking 8% of your new value and adding it to here. So you're adding 86.40 cents. And then to get to your new one, they're taking 8% of your new value and adding it. So it's gonna keep increasing more and more. Whereas here, you're just adding 80 each time. And obviously you wanna get as much money as you can. So you want to choose this option where your money is being compounded annually. Does that make sense? If not, pause this video, think about it, look at the previous two problems again, and really understand. So let's see, let's write an equation from a table. So let's think about the growth and the starting point of the investment accounts earning simple and compound interest in this lesson. Model each of the two accounts with an equation. And we already have our let statement. We're letting Y represent the money in the account after X amount of years. So as a reminder, exponential equations are Y is equal to AB to the X, where A is our starting value and B is our multiplier. And so if I choose value of bonds, okay, let's figure that out. Y is equal to, what is our starting value, our initial value? It's $1,000. Next, what is our multiplier? What is our B? Oh, I'm sorry, this is the linear one, right? Oops. So let me go back. Because we are adding $80 each time, What type of equation is it? It is a linear equation, right? So our linear equation is mx plus b. So what are we starting with? Remember, that is our initial value. And so the $1,000 will go here. Okay, and what is our growth? What is our slope? What is our rate of change? It's this 80. And that is our M. We'll call it growth. Okay, 80x. So there is our equation for the value of the bonds. Okay, now we can look at the credit union where it's compounded, and that's where we use the exponential equation. So again, what do I start with? I've got my $1,000, so that goes in for A. What am I doing to it each time? What am I multiplying it by? Well, it looks like I was multiplying it by 1.08. And again, I can confirm this by taking any of these values and dividing it by the one on top. So if you put 1080 into your calculator and you divide it by 1,000, you get 1.08. That is your multiplier. Boom, you're done. Okay, make sure these are not more complicated than they need to be. If you have a compounded interest problem or you have an exponential, here's your equation. You started with $1,000. You figured out what the multiplier was to the x power. And that is it. Linear, as a reminder from Math 1, right? Your B is your y-intercept, that's this guy. Your M is how much you're growing by each time, as long as the difference in X is by 1 as well. Just be careful with that. Because it is, you know, your change in Y is 80, your change in X is 1, so 80 over 1 is just 80. But that is it for writing equations from a table. Now, use your models to predict how much your original $1,000 investment would be worth at the end of 20 years. Okay, so let me think or remind myself, it was 80x plus 1,000 and 1,000 times 108x. Here, let me just write them down so I don't forget them. I've got y is equal to 80x plus 1,000. And I have got y is equal to 1,000 times 1.08 to the x power. So this part is fairly simple. It's just some plugging in and calculator work. Okay, so let's go ahead and try it. So it wants to know how much it's going to be worth at the end of 20 years. So what are we going to let 20 equal? 20 is going to be equal to x, because in our problem, it gave us the let statement that said x was the amount of years. And so x is going to be equal to 20. And all you have to do is plug in this 20 for x in both equations. So I have got y is equal to 80 times x, and we know x is 20. And then in my other equation, I've got y is equal to 1,000 times 1.08 to the x power, which we now know is 20. All we have to do at this point is a little bit of calculator work. So if I get my calculator, I do 80 times 20 is 1,600 plus 1,000. You are going to have $2,600 in 20 years, at the end of 20 years. Let's look at how much you're going to have exponentially. So be careful when putting this in your calculator. Typically you want to do this first and then multiply it by 1,000, because sometimes I'll see calculators and my students accidentally do 1,000 times 1.08 and then take it to the 20th power. So I'm going to take my calculator and I'm going to do 1.08 to the 20th power. 1.08 to the 20th power, and I get approximately 4.66. And then I'm going to multiply that by 1,000. Ooh, and I get $4,660 and about 96 cents at the end of 20 years. So where are you going to put your money? You're going to want to put it where it's being compounded annually, where you're getting interest based off of your new amount every year, as opposed to the linear one with simple interest, where you're just getting extra money based on how much you originally put. And that's not the best option. Now, in case that was a bit much, I also included this little math notes from the original textbook about simple and compound interest. I also have a copy of it in your Canvas modules in case you would like to print it out and glue it into your math notebooks. But this also just briefly goes over, if you want to pause the video to read this or read it after this PowerPoint, that is fine. Otherwise, that is the end of today's video. Let me know if you need more help, okay?